Hello everyone, welcome to the video lecture series on Basics of Electrical and Electronics Engineering on the topic Linear and Digital Electronic Circuits. So here, let us discuss about the following: the ideal op-amp characteristics, inverting and non-inverting amplifiers, and its applications, summer, flipper, and clamper, and also Boolean algebras, theorems, logic gates, half adders, full adders, flip-flops, analog to digital, and digital to analog conversion. Coming into the Boolean algebra, we generally know it is used to analyze and simplify the digital logic circuits. It uses only binary numbers, that is, zeros and ones. It is also called as binary algebra or logic algebra. So there are different theorems which actually deals with the binary systems or the Boolean algebras. We can say, for example, I have stated the few, namely the boundness law, which states that a plus 1 is equal to 0 and also a dot 0 is equal to 0. Here, let us assume that a is equal to 1, and in the first case, if it is 1 plus 1, again it is going to be 1, or in the second case, if it is 1 dot 0, it is again going to be 0. Coming to the next law, which is identity law, it is a plus 0 is equal to a, or a dot 1 is equal to 1. Assume here a is equal to 0, and you can see that 0 plus 0 gives you 0, and 0 into 1 again gives us 0. So idempotent theorem. So a plus a is equal to a, and a dot a is equal to a. Involution theorem, a dash of whole dash is equal to a. Again, you can see the theorem of complementary, commutative law, associative law, the distributive law, and the De Morgan's theorem. Coming to the absorption law, which is a plus ab is equal to a, or a into a plus b is equal to a. Similarly, you can look into all the laws and theorems. So coming detail into the logical gates. Generally, the logic gates are the basic building blocks of any digital system. It is an electronic circuit having one or more than one input and only one output. Truth table is shown here for all the inputs and the possible outputs. For example, the combinations of the inputs to the logic gate or the circuit. When putting values into the truth table, we often write them as 1 or 0. So these values are generally interchangeable with true and false. That is, 1 is true and here 0 is false. In the other way, we can say that 1 is the switch on and 0 is the switch off state. So here you can see the various logic gate symbols. So you can see the OR gate and its symbol, NOR gate and its symbol. Similarly, you can see the different types of gates. And now coming to the NOT gate. Here, the NOT operation flips a value to its opposite state. Say for example, if it is 1 is the input, the output can be 0. Or if 0 is the input, 1 is going to be the output. And here you can see its symbol and its relevant truth table. Assuming A to be its input and Y to be its output, you can see that if 0 is given as the input, 1 is the output, and if 1 is given as the input and 0 is the output. So this is going to give an absolutely inverse value of its input. So moving to the next gate, which is nothing but the AND gate. The AND gate operation produces only a true output if both the inputs are 0. So coming here, you can see the AND gate consists of two input, A and B, and one output. This is the actual realization of the gate. You can see if both the switches are on, you can have the output. You can see the lamp glowing here only when both the switches are on. Otherwise, it is going to get a 0 output. So the same is shown in the truth table as if the inputs are 0, 0, the output is going to be 0. If the input is 0 and 1, the output is 0, meaning that any one switch is off, so your output is also going to be off. So now coming to the next combination, 1, 0. The same is the case, assuming switch A is on and switch B is off. So the output is again going to be off. And now coming to the last case, where both the switches are on, or it is 1 and 1. So the output is going to be 1. Thank you. Let us continue the remaining class in the upcoming classes. Pause பண்ணி வச்சிட்டேன்.